So as Abir said, my name is Ryan. I'm currently attending Amador Valley High School. And when I was a kid, I played a lot with remote controlled cars and drones. So I thought it would be fitting here at Bootcamp to make my own remote controlled car, while also implementing alternate control method, which is this gesture controller that allows me to mirror the movement of the car in my hand. And then I also have a joystick for your traditional RC car move method. And then on the car itself, I have positioned 2 ultrasonic sensors that can detect the distance of an object in front of them. And then using that information in the code, I can have it stop before it hits something in front of it, for example, the wall. So I'll just begin with a quick demo. It's going to take a sec to power. So if I have it move towards the wall, camera. Alright. It seems I accidentally left the batteries on, so I'm just going to go ahead and replace this 9-volt. Hopefully that'll give it a better response. So I have the motion gesture. So I have this controller in my hand. Depending on the tilt, the car will move in that direction. So if I have it go forward, it'll go forward. And that was the ultrasonic sensor you just saw working there. It detected that there was an object in front of it, which is the wall, so it stopped. However, it can still go in all the other directions. And if I want to test the other ultrasonic sensor, it'll only go when there's nothing in front of it. And I have this button here on the controller, so it'll cease to take input from the motion controller, and it will instead take input from this joystick. And then once again, the ultrasonic sensor is preventing it from running into the wall. And if I turn it around, it does the same thing on the other side. So that's just a quick demo. Sorry about that. I forgot to unplug the battery, so it was kind of dead. It wouldn't have worked. Yeah. I would say that throughout this entire project, I faced a lot of challenges. One of them was configuring the Bluetooth. There were a lot of steps involved, and even when I thought I had it right, it took a long time for me to get the 2 modules to actually read and write data between each other. And once I was able to do that though, I implemented it into my code and made it a truly remote control system via that Bluetooth that can send the controller signals. Another challenge I faced was the ultrasonic sensors. I wanted to implement object avoidance, and I didn't know how these ultrasonic sensors worked. So first of all, I had to research how indeed they did work. And if I was just to explain it to you quickly, if I put this remote here, the trig pin will send a sound wave. It'll hit here and it'll bounce back and it will be received by the echo pin, right? It's just on the module, specific names for the receivers. And then the raw value I get from that is the distance to the object and back. So with manipulation in the code, I can then find the distance from this sensor to the object itself in desired units, which is what I did. And then I can implement it in my move method so that the car so that it overrides the input from this motion controller. And I would say another very difficult challenge I faced was power distribution. When I started off with this car, I had a lot less components, less modules, and it was a more bare bones system, but as I added modifications, the power system I currently had wasn't working anymore. And a lot of the times I'd spend time troubleshooting an issue, and it turns out the issue was there wasn't enough voltage and power. So I had to redo my power system, and when I figured that out, I also got the hardware, as you saw there. And I would say if I had more time to work on this project, I would create like a casing for this controller. Like you guys saw me fumble with it a little already. It's a little unwieldy, and also these wires are really easy to accidentally unplug. So creating a casing would make it more usable. And for the car, you can see already that I have like omnidirectional wheels here. I didn't have time to fully implement them before this demo tonight, but I definitely will be pursuing that after today. I'm sorry I can't show you guys today. And lastly, I think through finishing this entire project, working through it, the biggest thing was that reaffirmation of the learning mindset. Because in engineering, when you're solving unfamiliar problems, a lot of things go wrong. In fact, it's a given, things will break. And when I have this controller, this car, so many chips, modules on here, even more on here, an updated power distribution, things did go wrong. A lot of things went wrong. A lot of things broke. I spent a lot of time troubleshooting, spent a lot of time trying to solve the problem, and when I got through the process, I think the most important thing I learned is how all these components work together to create the final product that you just saw.